Hello everyone. So in today's session we'll discuss the third experiment, the third program NS2. That is, the statement of the third program is implement Ethernet LAN using n number of nodes. Here n number of nodes, generally we can select which varies from 6 to 10 nodes. What is required here is we have to compare the throughput by changing the error rate and the data rate. Okay, so two parameters we have to vary, error rate and the data rate. Once you try with the error rate, keep data rate constant and check what happens to the throughput. Similarly, you keep some error rate constant, vary the data rate and check for the throughput. Okay, so this is what actually we have to perform the variations with respect to the parameter and analyze the result. Okay, error rate and the data rate should be introduced. Don't keep on change both here. One you keep constant, another you can vary and check the result. Okay, and here one more important thing is it is not our simple like a duplex link between all the nodes. What we have to create here is an Ethernet LAN. Okay, we are concentrating another very important structure, that is a LAN network. Okay, so now some question comes in your mind, why the LAN is required, why I cannot apply duplex link for all such connections. Okay, so let's assume you are belongs to some group of, like you have some group of machines in, okay, let's take our laboratories, DSP lab, n number of systems are there. I want to communicate between all the systems and there should be a communication one-to-one between all the n machines. But if you create the duplex link between so many devices, then the complexity of the link increases. N number of links I need to create between all the devices. So in order to avoid that, whenever you have to broadcast the message, whenever it is required to broadcast a message, then I can connect how many devices are there. Like for example, all the devices I will be calling as a node. Connect all the devices to the LAN network. Okay, then I will be creating a window between some two nodes through which another LAN can be communicated. Okay, so just an example, just imagine all the devices of DSP lab is connected with one LAN network and all the machine which is present in the VLSI lab are connected with another LAN network. Now I want to communicate one machine of my DSP lab with respect to one machine of my VLSI lab. How they can communicate? The communication between is through doors only, is between the doors which is open in between those two. That is, we will call in here as a duplex link. Okay, so here as I have shown the structure, LAN 1 and LAN 2. For each LAN, some set of nodes is connected. In between this, if for example N0 wants to send some information to N8, how it can be done? So N0 will send the information to LAN. From that LAN, I will be selecting a main node as N4 that is connected to LAN 2 with the node N5 by means of duplex link. N4 to N5, I will be creating a duplex link. Then N5 will send the information to this LAN. Whichever wants to receive, they can receive the information and only that machine can reply for that answer. He can give the answer for that sender information. Okay, similarly you can create any node from LAN 1 can communicate to any node of LAN 2 only via the duplex link which is created between N4 to N5. So what are the important things you need to remember here is I have to create a LAN LAN 1, another LAN 2, then the duplex link between two nodes. Okay, rest of the things is remains same. So you know how to declare the node N0 to N9, just declare the node as it is. Okay, so we'll start. What we have to do first, create the simulator object, simulator instances first, then create a trace file and the num file settings. Then I have to create 10 nodes. Okay, just the same example, same syntax, but the variable name changes, n node to n9, 10 nodes. Then I have told in the second video how to declare the LAN. Here also I will repeat. So in order to declare the LAN, the syntax is object name. I am accessing to my object. The name of my object is myns. What I am doing? I am creating a LAN. So make -LAN. How many nodes belongs to that LAN? N0, N1, N2, N3, N4. That should be specified within the double quotes. And I can declare the parameters for that LAN also in terms of its bandwidth and also in terms of propagation delay. Okay. Then type of the LAN is a logical link and queue type is drop tail. So the LAN according to IEEE standard, it is MAC protocol of 802.3. 802 point is represented by underscore. Okay. Similarly, you need to create another LAN between the node N5 to N9. Okay. So these two statement is going to give you a two LAN structure, a LAN 1 and LAN 2. Then what you have to do? I have to create a duplex link. As I said, communication should take place between only two nodes. So those two nodes I have selected as N4 from LAN 1 and N5 from LAN 2. Means I am communicating from this node to this node of different LAN. So for that I have to create a duplex link. Okay, with some bandwidth and then propagation delay. And how it is oriented, just write down. Means LAN 2 is oriented, N5 is oriented right down with respect to N4, with respect to N4. So that means upper part you will be having LAN 1, lower part down you can see LAN 2. So in the program I have to select some specification for source and the destination. So node N node is labeled as TCP source, N2 is labeled as UDP. So you can do the changes here. It is depending upon the programmer in what way you want to access, you can do the changes. So N7 is sync, N9 is null. Then I will be differentiating packet transmission with the two different colors. Okay. Then according to the labels what we have given, the node selector has a transmitter and the receiver with the different packets. I have to declare its TCP agent and then UDP agent and then its traffic of application layer. Okay. With respect to the nodes, which one you are selected, how you are accessing is given here. Accordingly you can follow the syntax. So then I will say, I will create some instances when the schedule should start for sending TCP packet or CBR packet or FTP packet, when it should start and when the packet stop sending, and what is my final finish time. Okay. So as you have seen in the previous programs, I need to give finish procedure is common for all the programs in order to trace my num file and then tracing file and also execute these two, out.nam and out.tr. Okay. So next, as in this program, in between the two LAN, the duplex link is created from N4 to N5. I have to introduce error rate and the data rate. Where this error rate and the data rate is introduced, that is only between the node N4 to N5. So how I can access varying the data rate and the loss rate? For that, error model has to be introduced. For syntax, for writing the error model also I have given in cheat sheet. You can go through the things over there. So here set error of new error model. So first I will be telling loss model between N4 to N5 duplex link, and initially I have set the error rate at 2. Okay, let me make this as 1. Okay, so we will start from 0.1, 0.2, 0.3, 0.4, 0.5, like that we keep on increase the loss rate, and we will see what happens our throughput. Okay, we will see what happens to my throughput, and then I will be calling run. Okay, so in this program actually I have to invoke another program known as n3.awk. Okay, for this n3.awk, the main concept I have to write here is how to evaluate throughput. What is throughput? Throughput is nothing but the amount of packet transmitted over a particular instant of time. So how many packet transmitted with particular duration, simulation time. So what do you mean by packet? The packet transmission may be either CBR packet or TCP packet. What is the simulation time? How to evaluate? So start time, stop time minus start time will give you the simulation. So how I can implement this program? So I will show you how that program is executed. First I will see the AWK script, then we will go back to the program execution. So let me access the program here. Okay, so I have opened n3.awk script. Okay, so when you see this program is mainly written in order to analyze the simulation result through trace file format. So trace file format, as I said, it just looks like this statement. Okay, it looks like this statement: sum of the event, time duration, which node to which node, what type of packet, and what is the packet size. Okay, if you see with this, each parameter in this is accessed with a dollar sign, $1, $2, $3, $4. So I will call these parameters with some name. $1 is nothing but event. So $1 is assigned to event. $2 is nothing but simulation time. $5 is application type. 3 and 4 represent source node and the destination node, and 6 indicates what is the packet size. Okay, so in order to calculate the throughput, we need some variables. So for that I have taken some set, that is total packet, total byte, time, packet size of CBR and TCP, what is the throughput, simulation time, start time, stop time, CBR packet count, and TCP packet count. So by using these parameters and accessing the event from each row of the trace file, I have to implement the program. Okay, so what is the program here? Let's see. If first I will be counting how many TCP packets are sent from LAN 1 to LAN 2. So for that I will be checking event. If event is plus or, okay, received also you can take, or NQ packet is also you can take. So and source node is from 4 to 5 because I have created a duplex link from 4 to 5. And what type of packet? This is TCP packet. If all these 4 condition is satisfied, then increment TCP count by 1. Okay, and with this TCP count, current packet size is also incremented, and whatever the current packet size value is there, that I will be giving to the TCP packet size. Initially current packet size is 0. Current packet count is also 0. But at that particular, at this instant of time, packet size is different because some of the TCP packet is added. So that will be given to TCP packet size. So similarly, you have to count how many CBR packet has been sent between node 4 to node 5. Okay. So in the similar way, I will be accessing for CBR packet. So now at this instant of time, for 10 milliseconds, I have evaluated all the packets, TCP packet and as well as CBR packet. So now I have to find what is the simulation time. So simulation time is what? First I will check. Initially time is 0. See here, time is 0. This time is 0. Variable initialization to 0. So if this time is less than start time means what? I have not started my program execution. Then this part will not execute. So once this time is greater than start time, that means the program started execution and that particular time is initially given to start time. So next, how to find the simulation end time? If this time is greater than the stop time, okay, greater than the stop time, then the stop time is equal to this time. So now here the variable start time is having my start time value and stop time will be indicated by this variable. So what is the simulation time? Simulation time is nothing but stop time minus start time. Okay. So at this time, by means of all these 4 variables or 4 different initialization of with respect to if statement, I have what is the total packet size. Total packet size is nothing but CBR packet size plus TCP packet size and my simulation time. Then I can execute my throughput. Okay. So after this evaluation, you can evaluate some of the parameters. You can evaluate some of the parameters and then you can print those parameters. So what is first? Total byte. Total byte is nothing but TCP packet count into its size plus CBR packet count into its packet size. Or else you can, this is in terms of byte, but in terms of total packet you can just evaluate TCP packet count plus CBR packet count. Then what is simulation time? Stop time minus start time. Okay. Then what is throughput? Throughput is nothing but total byte. So here the packet in terms of its bits. Okay. I want in terms of bytes. Hence total bytes, actually throughput is kilobits per second. The throughput will be represented by kilobits per second. But here packet will be evaluated in terms of byte and time is in terms of millisecond. So in order to change that unit, I will be multiplying total bytes by 8 and simulation time is in millisecond. Just I am converting that in terms of second. Okay. So now I have got these values. Just I will print those statement here. Total packet sent from node 4 to 5, total bytes sent, total simulation time, and what is my total throughput. Okay. I hope the concept of this writing AWK script is clear with everyone. So we will see the result by varying the parameter. First I will check with respect to loss error rate. Similarly you can check for data rate changes also. Okay. What is the execution step? ns space n3 dot tcl. Okay. So when you execute this, see here, what is my throughput? Total packet sent from N4 to N5. Okay, so somewhere that backslash and I will be, okay, not a problem. Total packet sent from node 4 to 5 is 1601 packet. Total byte sent is this much. Multiply this value with 8, you will get this value. Okay, this is in terms of byte. This is in terms of bits. Then what is the simulation time? This is in terms of seconds. And what is my throughput? 721 kilobits per second. Okay, this is for first case. So now I will show you in the animator file. This is my LAN 1. This is my LAN 2. See, already packet drop is increased. If you keep on increase this, another packet is also started sending, hence packet drop is more. Okay, so this is just a animator file. You can view how it works, how the LAN is created, and how the packet drop is taken place. Okay, but you cannot check exactly how many. We will not get any numerical result. So for that numerical result, I have to verify, I have to work with a trace file. Okay, so now I will go to program n3.tcl. just I will actually what will result we have got for this. I will clear the result. So what is the so I will close this also. So when my loss error rate, my error rate is 0.1, then I will be getting the throughput is 837 kilobits per second. Okay, 837 kilobits per second. So now I will change the throughput. I will just increase the throughput. So from 0.1 to 0.2, then do save the program. And every time I don't want to execute my animator file, so I will comment that. Okay, so when you okay, I will save that also. Whatever the changes you will do, you have to save it, then execute with the same command. So what is the answer? 721. When it changes to 0.1 to 0.2 here, then it decreased from 837 to 721. So let me do changes again. 0.2 to 0.3. Again save. Then go to terminal window, execute. Then it reduced to 614. Okay. So what is the outcome now? 614, 721, and then we have got here 837. So our throughput is keep on decreasing. Okay. The conclusion here is, as the loss rate increases, the throughput decreases. Is clear? So for this variation, I have kept my data rate is constant. Now you keep error rate is constant. Do the changes with data rate and try to check what are the changes and what inference you will get from these variations. Okay, so this is about my third program. So here in another way also you can access the AWK script. Directly you can write AWK script with respect to its $sign also. Okay, so I will show you just how to write the AWK script. So gedit n31.awk. I think I have this n31 script. We'll see. It is opened. Yeah, n31. See, this is another way how you can implement. Just I have declared some of the variables in order to evaluate the transition, total packet, time, size, throughput, CBR packet, TCP packet. Then I have not assigned this $1, $2, $3 to rest of the variables. I have taken directly in order to access the particular event. So if $1 is plus, if $3 is from node 4 to node 5 and $5 is my TCP agent, then increment TCP. If $1 is this and $3, similarly you can go with the CBR. Then evaluate the simulation time. Simulation time is second event, that is assigned to time. So with respect to this also you can evaluate. It is simple, but it is a good practice if you follow this program. Okay, if you follow accordingly by assigning with some variables and all, this is a good practice for you so that you can realize easily. Okay, just I have shown here. This can also be used in order to get the relevant results. Okay, thank you. Do the changes with the data rate and verify the result. Get the inference between both what happens to the program. Okay students, thank you.